Okay, so what we're going to do really fast is kind of a quick review of vectors, and we're going to do some example vector operations, some math operations. So let's get into that. When we talk about vectors, we're talking about a set of numbers that represents magnitude and direction. Okay, so usually when we think about this, or a lot of times when we think about it, we do it in 2 dimensions. And the way we've all been kind of taught is that we have an x direction and a y direction. Okay, so a vector is something that starts at the origin and then goes to some point here defined by some numbers. So let's give an example here. We have a vector v that has components vx, which is the vector's magnitude in this direction, and then vy, which is the vector's magnitude in the y direction. So as an example, we might have something that is 1 and 2, let's say. So vector is equal to 1 and 2. Well, in order for that to have any meaning, we have to have a scale here. So to actually draw vector v, we're going to have magnitude 1 in the x direction and 2 in the y direction. So vector v would look like that. Okay, but our world isn't flat. It's got 3 dimensions, so we try to represent it in an appropriate way. And the way we do that is we draw a 3-dimensional set of axes here. Now, in this class, what we use, instead of x, y, and z, is we use I, j, and k. And what are these guys? Well, they've got little hats on them, which tell us that we have unit vectors. So let's take a look at what a unit vector is. All a unit vector is it's a vector with magnitude 1. So it has magnitude and direction. Its magnitude is always 1, and its direction is in the direction that we specify. So I hat is going to be in this direction, j hat's in this direction, k hat's in this direction. So let's draw those guys. What I hat would actually look like would be something like that. What j hat would look like would be something like this. And what k hat would look like would be something like this. So then we can start to specify vectors, and we say they have some value, and we can call it vi now, in the I hat direction, plus vj in the j hat direction. And usually we actually don't say that that guy is got a hat on him there, vj. And then we have vk in the k hat direction. Okay, so you can imagine we could specify a vector, and using our old notation that we talked about above, the I direction would be the top, and we could say it's 1, and then 2, and then 3. So this is its magnitude in the I direction, j direction, and k direction. So the equivalent way to write that would be 1i plus 2j plus 3k. And well, what would that vector look like? If we drew it out over here, it would be 1 in this direction, and then 2 in this direction. So if we projected it here on this plane, it would look like that. Then we go up 3. So this thing, you can imagine, is coming from the origin there, and I'm going to draw the head like that, so you can kind of see it's coming out toward us, and that would be the v vector. Okay? So we specified v as 1, 2, 3, and we're going to specify another vector here, w, and we're going to say it equals -1, 0, 4. And the reason I'm specifying a second vector is we're going to start doing some math operations. Okay? So what can we do with vectors? We can do addition, subtraction, and then I'm putting quotes around this, and I'll show you why. Multiplication. And I put the quotes around it because we have actually 3 different types of multiplication that we do with vectors. One is a scalar multiply. One is a dot product. And one is a cross product. So what's the difference between these? Well, when we do a scalar multiply, we take a number that's just single valued, a scalar, so it has magnitude but no direction. We'll call that A, and we multiply it times one of our vectors, V, and what we get out of that is a vector. Dot product is going to look like, it's going to be 2 vectors multiplied together to give us a scalar. And then we're going to have a cross product, which is where we have 2 vectors crossed together, and that gives us a vector. So let's do some examples of these. We'll start with addition, and we said our v vector was 1i plus 2j plus 3k. We said our w vector was equal to negative 1i plus 0j plus, is it 4k? Let me check. Yep, negative 104. Okay. So if we're going to add these 2 vectors, we just call it v plus w. And we're just going to add them component-wise. It's going to be 1 plus negative 1, 0, I, and then 2 plus 0, so it's going to be plus 2, j, and then it's going to be 3 plus 4, so plus 7, k. So pretty simple, and v minus w then, it's going to be the same kind of thing, but it's going to be 1 minus negative 1, 2, 2 minus 0, 2, 3 minus 4, negative 1k. So that's addition and subtraction. Now let's talk about scalar multiplication. So let's define a scalar a, and we'll say it's equal to the number 2. So if we say a times v, that's going to be equal to 2 times this vector up here, and we just multiply 2 times each component. So it's 2i plus 4j plus 6k. Alright. Now dot products. So we're going to have v dot w, or 1, 2, 3 dot negative 1, 0, 4. So here's how we do dot products. All we do is we multiply them component-wise, but add up the sum of those multiples. So it's going to be 1 times negative 1 plus 2 times 0 plus 3 times 4. Because remember, we're going to get a scalar from this. So this is 1 times negative 1 plus 2 times 0 plus 3 times 4. And that's just equal to negative 1 plus 0 plus 12. So it's equal to 11. So fairly simple. But remember, this is a scalar. Whenever you see a dot product, you should be thinking, I need to get a scalar answer, and you go through this process to get it. So now let's talk about the one that people struggle with the most, which is cross products. So in this case, we're going to do this again. 1, 2, 3 cross negative 1, 0, 4. So there's really a process that you just kind of have to memorize to do this, and it involves kind of a scary word for some people. It's determinants. So what does that mean? Well, the way we actually write this out is we do a determinant. So it's going to be, and we draw this I, J, K. Now, some people do this a different way. This is the way I learned, so it's the way I'll teach you. And we take V, and we write it in the second row. Whatever's first here has to go in the second row. Whatever's second goes in the third row. So 1, 2, 3. And note that we're having 1 is the I hat direction, so it goes in our I hat, and so on. And then we have -1, 0, 4. Okay, so we're going to take the determinant of this matrix. And it's not hard, you just kind of have to remember how to do it. And the way you do it is you say plus I here, we're going to have a minus J, and we're going to have a plus K. And these are our components, and this is very important that you memorize this order. It's plus I, minus J, plus K every time you do this. And in this little multiplication here, so we're talking now what's going to modify I, how far in the I hat direction are we going to go. And the way you do this is you take make this little pattern here, right? Kind of a tic-tac-toe board, but not quite complete. And when we're doing the I part, we cross out this and cross out this. We can block them out with our hands or whatever we want to do, and we take the determinant of whatever is left. Well, how do you take the determinant of a 2 by 2? It's actually pretty simple. You say this component times this minus this times this. So in this case, it's 2 times 4 minus 0 times 3. Okay? And again, it's all about kind of just memorizing how this whole thing is done. So for J hat, we're going to do a similar thing. We're going to cross out the row. So we're just finding where J hat is. We eliminate that row. We eliminate that column. We take the determinant of whatever's left. So it's 1 times 4 minus -1 times 3. 1 times 4 minus -1 times 3. And then for K hat, kind of cutting into each other here, so I'll fix this. So plus K hat. And now we go cross out or kind of cover this with your hands, the K row and the K column, and now we have 1 times 0 minus -1 times 2. 1 times 0 minus -1 times 2. Okay, so what does that give us? It gives us 2 times 4, 8 minus 0, so 8I minus 1 times 4 minus -1 times 3, so that's 4 plus 3, 7J. And now we do this, 1 times 0 is 0, minus -1 times 2, so plus 2K. Or if we rewrite this out, we get V cross W is equal to 8I minus 7J plus 2K. Most common mistake is people forget that the second component is a minus, and they would have a plus 7 here, which is wrong. Okay, so just go through a lot of your calculators. More expensive calculators can do cross products. If you look in your manual, you can come up with an infinite number of examples here. I'm sure you can find plenty of examples on the internet, but you have to just work these until they become second nature.